Harshagar, we can hear, but I think
Yeah. Now I can hear you, sir. Now I can hear you.
You can hear me? Good.
Yeah.
Okay, I want to keep this Wallah
Yeah.
background. Give me a
Please,
second.
sir. Please.
One second.
Yeah.
We do that. Configure virtual background. Okay.
Yeah.
I have virtual effects.
In the left side, it's last is there, sir.
One second.
Yes, sir. Not issue.
Correct?
Sir. Start, sir.
Okay.
Good. Yeah.
Hi, all. Very good evening. Okay, let me introduce myself. After that, I will get the brief introduction from the participants. Then we will start the session. Okay, I am Jairam. Okay, I have around 18 years of experience in the IT industry. Okay, I have the exposure to the different software technologies, maybe in the field of software development, as well as software testing, quality assurance. Okay, now currently I am working for the Devops specialist along with the cloud technologies like AWS Cloud and Azure.
Sorry for interrupt. 1 second.
Yeah.
1 second. I'm going to live the session. 1 second, sir.
Please. Yeah, make it live and then let me know.
1 second. Sir, start, sir. Hello, Jairam, sir.
You can see my screen now.
Yes, sir. We can see, sir. No, it's blurring.
I think he's stuck. We didn't see anything. Yeah.
Once again. Can I share it once again now?
Sir. Share, sir.
Yeah, let me know. Yeah, let me know now. You are sharing yours.
Yeah.
Stop.
Now it's coming the session. Yeah.
Yes, sir.
Good. Okay, that's fine. Okay, fine. Okay. Well, that is about brief introduction about myself. Okay, I have total 18 years. Currently working as a Devops engineer along with the cloud computing. And the today's session it is going to be the importance of the DevOps tools, what we are going to use for the software development, and the importance of the cloud computing. Okay, why we are going for the any cloud computing. Okay, that is also we are going to put the focus and see that what are the benefits that you can get it by applying of the cloud technologies for your software development. That is in brief about myself. Maybe one by one, quickly introduce about yourself. What is your background, please? I'll go with Vinay Krishna. Can you briefly tell me? Unmute your audio and let me know.
Yeah. I'm also a software professional, and I just moved
Okay.
from US to here. And now we're
Okay.
doing the agripreneur and entrepreneur of the clothing related, and parallelly
Years of
working in IT
experience you have?
services. I have more
Yeah,
than 12 years.
12 years. Very good. Very
Yes.
good.
Yeah.
1 second. I will go with the other person. Okay, Krishna, that's I got it. And now audience 6, Vinay Krishna. Okay, another Krishna is there. Can you please unmute your audio and briefly
Hi, sir.
describe about it? Yeah.
Myself, Krishna. I have totally 10 years of experience, sir. My career started with Linux administrator. So I am looking for a moment of nowadays, from the last 5 to 6 years, the DevOps is booming. So I want to know something about the DevOps tools, sir. So which tools we need to use? So we need to emphasize about the session, sir. So because
Yeah.
we have already joined for business operations for Wallah. But anyhow,
Okay.
here is a IT business also. It's going on here,
Yeah.
so it's a really very helpful to all of us, sir.
Yeah. Yeah.
Thanks.
Thanks for that
Yeah,
introduction. Yeah. Guna
thank you.
Balan. Guna, can you please unmute and then briefly
Yeah,
describe about?
hello. Good evening, sir. Good evening, everyone.
Yeah.
Myself, Gunabalan. I am into business in Coimbatore, Tamil Nadu.
Okay.
I am into
Okay.
FMCG distributor for food products
Okay.
like coffee and spices. I'm attending this session for somewhere this cloud computing can help me in marketing or
Okay.
these areas.
Yeah. Thanks, Guna.
Thank you.
Mohammed.
Hello, can you hear me?
Yeah, I can hear you.
Yeah, hello everyone. My name is Nizam, Nizamuddin Mohammed. So I have
Okay.
around 15 years of IT experience. So I have my own products. I lead the AI and Gen AI practice here. So
Okay.
so I am
Very good.
looking for someone like-minded folks who can work with me, because we also work on few consulting opportunities from across the world. Like if there are any
Okay.
like-minded people who wants to work with me, you can connect with me so we can discuss. Yeah.
Fine. Fine. Thanks. Thanks a lot. Sudeep.
Hello,
Sudeep,
sir.
can you unmute? Yeah.
Sir, ಅದೇ ಇದು ಕ್ಲೌಡ್ ಕಂಪ್ಯೂಟಿಂಗ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಳಕ್.
Yeah. Go ahead, please. Yeah.
Hello.
What is your background?
MBA.
MBA. Okay. You are new to IT industry, or you learned something, some of the tools or anything cloud related?
Yes, sir.
Okay. Okay. Fine. Thanks. Thanks for the introduction. Very nice introduction from all of you. Appreciate that. Okay. Yes. One second. Fine. You can see my screen, right?
Yes.
Yeah. You can see my screen. Good.
Yeah.
Yes, yes, sir.
Yeah. One second. Yeah, still you can see my screen. Okay, fine. Thanks for all of you for giving up the brief introduction about yourself. Okay, now we are going to focus the different DevOps tools. What is a DevOps, first of all, and why people choosing the DevOps, okay, in their general day-to-day practice to develop any of the software development, and what are the different, what is the DevOps methodology? Okay, what are the benefits that you can get from the DevOps compared to other, methodologies which are available in the IT field. Okay, and currently, what are the different DevOps tools currently which are there in the market? Okay, how we are going to use those tools for our day-to-day software development, and what are the benefits that you can achieve using the DevOps tools? Okay, those details and all we are going to discuss it in today. Okay, once we'll complete the DevOps tools, the next thing is we are going to see the cloud computing. The cloud computing, of course, we have the different types of the clouds which are available in the market as a public cloud. Like we have AWS, Amazon Web Services, we have Microsoft Azure. Okay, and the third cloud currently which is there in the market is called the Google Cloud Computing. Okay, there is other cloud providers are there, but we are going to see more onto the AWS cloud features. Okay, now this is the agenda for the today's course. Okay, now I'm going to talk about the other methodologies which are available in the market, and we are going to see what is a DevOps, and in the DevOps, what are the benefits that we can get compared to other models? Why it has become so popular in the today's current scenario where we are using this methodology for development of software. Okay, the importance of that we are going to see, and the tools, the DevOps tools. Here some of the tools that I have listed here. we are going to see the tools like Git, which is the configuration management tool to maintain your software. No, we are going to use the Git and GitHub. Okay. And once if you develop the software, the next thing is we are going to build that software. For that, we have a lot of tools available, but we are going to focus on Jenkins, which is the open source, freely available software to download and use it for the building of your software to make the object out of it. Object in the sense, the artifacts, the final application which is going to use to deploy onto the clusters. That is where Jenkins plays the major role. And the next tool we are going to use is called the Terraform. Maybe we'll see the in detail, using which you can deploy the infrastructure onto the cloud environments. Maybe I want to deploy some of the servers, or I want to deploy some of the hard disk, the volumes onto the AWS cloud, or I want to set up my Kubernetes cluster. The other thing is I want to do like set up a virtual private cloud. For those kind of operations, okay, we can call the Terraform. The Terraform is nothing but using the code, you can create the infrastructure onto the cloud. We are going to see the Terraform. And the next tool we are going to use called the Ansible. What is the Ansible? Ansible means once if you deploy the infrastructure on the cloud, right, on top of it, I want to install some packages. Maybe I want to install Java, I want to install Python, or I want to set up some Nginx web server, which is load balancer kind of thing. For that purpose, we can use the tool called Ansible, which is the configuration management tool. After that, we are going to see the Docker containers. Like Docker containers is mainly used for the microservices based applications development. We can use the Docker containers. Okay. This is for the small scale. If you want to deploy the applications, you can go with the Docker containers. Or I want to set up the bigger infrastructure, bigger enterprise related applications deployment. No, then you can go further. There is one more tool called the Kubernetes. That is called, short name for that is Kubernetes. In addition to this, we are going to talk about some observability tools for monitoring purpose. No, we have the tools like Prometheus, Grafana, ELK Stack, those kind of tools. We are going to see a little bit about that. After that, we are going to enter into the cloud computing. In this, we are going to put the focus towards the AWS cloud, which is the public and private cloud offerings from the Amazon. Okay, that cloud computing, we can call it as Amazon Web Services. In that, there is so many services are available, maybe around, I can say 200 to 250 services. But we are going to focus on some important cloud services that is called EC2, that is Elastic Cloud Computing. EC2 stands for. And the second one is called S3. S3 stands for Simple Storage Server. Okay, I want to set up some hard disk, or I want to set up some object storage for my requirement. Then I can go with the S3. The other thing, I want to restrict the access to my cloud environment. For that purpose, I can define the different users, groups, and roles. For that purpose, there is a service called IAM. IAM stands for Identity Access Management. Okay, now I want to set up my own data centers in the cloud. For that, there is a feature called VPC, Virtual Private Cloud. Not only that, I want to set up my own databases. Okay, no need to buy some database from some other vendor and then you can install. There is a readily available database services available in the cloud. That is called RDS, Remote Database Systems. Okay, and for monitoring of my applications behavior and all, there is another tool called I want to build again some applications in the AWS itself. For that, we have something called AWS Code Build, Code Deploy, and Code Pipeline. These are the tools which is discussed in the above, like a DevOps tools. Same thing you can achieve in the AWS cloud environment also. And I want to monitor my application's behavior. There are the tools like services called CloudWatch and CloudTry. There's one more service called AWS Lambda, which is the serverless computing feature in the AWS cloud. Okay, we are going to see these tools and different cloud computing services one by one. One second. Okay, now let's talk about DevOps. Fine. If you want to talk about DevOps, before DevOps, right, we have the other methodologies which will be used for the software development. If you see the olden days, for example, 20 to 25 years before the software development, at that time there is no DevOps model into the existence. Okay, at that time people used to follow the model called the waterfall model. The waterfall model, maybe if you see the different stages of the software development, okay, let me write it so that you will get the better picture. Okay, any software, one second, one second. Okay, fine. See, any software development, if you want to do, what is the first stage is called? The first stage is called requirements gathering. Requirements gathering. Okay, the second stage is called design. Okay, in the design there are two types. One is called low level design. Sorry, first one is called, I can say, high level design. Okay, second one is called the low level design. What is the third thing you will do? Once the design is complete, you will do something called coding. Okay, once the coding is done, then what you will do? You will do something called testing. Once the testing is done, what you will do? Fourth thing called deployment or delivery. Deployment or delivery. Okay, and the fifth stage I can call it as is called monitoring stage, maintenance. Maintenance, or I can say monitoring. Okay, why I am talking about all these things is I want to differentiate the waterfall model with the DevOps model. I am not taking other models. There is so many other models available. There is something called spiral model, agile model, and we are going to see the difference between the waterfall model versus DevOps model. We are going to differ waterfall model versus DevOps. Okay, fine. See, in these phases of the software development, whatever that I mentioned here, in the olden days, right, people used to mainly focus on requirements, means they will focus on requirements only. Okay, they won't shift to other design and other things in parallel. Okay, first they will gather the requirements. To gather the requirements itself, it will take couple of months. Okay, couple of months. For example, you have the client called X client. Maybe, sorry, for that X client, let's take an example of take for example Reliance. Reliance is your client, and Reliance is approaching you to develop some of the the software application. Then what is your first step? You will approach to the Reliance, and then you will gather the requirements. That gathering of the requirements, you need to understand their business. You need to understand their different departments, what they have, and their business model, and the way how they are operating their business, everything. And then you need to convert those requirements into the software development modules. That is called the requirements gathering. Now, after that, what are the companies will do is they will do something called high level design. In this, the requirements are divided into different subcomponents. Okay, that is called the high level design. Maybe between this first phase to second phase, you will take some months together. Maybe first 1 month you have taken for requirements gathering. If you want to do high level design, it may take another 3 weeks. Okay, for the high level design. Maybe in between, you are going to interact with your company team and then trying to get them more clarity. After that you will do the low-level design, then you will do the software coding. Once your features are ready, then you are going to do the testing. Testing means the features working fine or not. Then you will do the deployment. What is the deployment? Once your software features are working fine, you are going to deploy this application onto their servers, or it could be their private data center, or they will say that they will request you to deploy onto the cloud environment. You can deploy it there. Once it is deployed there, these applications can be accessible through the internet with the given IP address and the domain name server, whatever the domain name which is given for that application. Okay, once the applications are running on the internet, then second thing is you need to keep on monitoring of your applications. What is the performance, how it is behaving, and all those things. Okay, these are the stages. In the waterfall model, right, what it is to happen to develop all these phases, all the 5 phases I have taken. In the waterfall model, what used to happen is phase by phase, people will develop 1 month for requirements, another 3 weeks for the high level design, another 2 weeks for the low level design. Coding, it may take another 1 month. This testing take another 1 month. Deployment may be 3 weeks. This is for 2 weeks. The entire stages development, it used to happen in the sequential way. Okay, there is no interactions between one team to other team to have the good collaboration in the waterfall model. That is why the turnaround time it used to take to develop any of the software applications, it used to take more time in the waterfall model. Assume that all these stages, if I want to develop, it may used to take 1 year. Now what is happening, instead of the waterfall model, the latest, maybe there is other models already existing in the market. Maybe something called they will say there is something called spiral model, there is other thing called agile methodology, and there is a scrum methodology people are using. As part of the scrum methodology, they implemented something called the Devops model. What is a Devops means? Dev plus ops. DevOps, it is a combination of development plus operations. Okay. Now, if you take the software development teams, right, what will happen is there are the developers will be there. Developers will be there, and you have something called testing teams. Okay. Teams will be there, and you have something database teams will be there, and you have networking team, network team. You have something called options. Any issues? You can hear me, right? Any issues? Yeah, tell me. Hello.
Hello?
Harsha, you can hear me, no, clearly?
Yeah, I can hear you, sir.
Fine. Yeah, what I'm talking is, in a software development, right, you have the developers, testing teams, database teams, networking teams, and operations team. Okay, in case of the DevOps methodology, what used to happen is, see, DevOps right, the development teams plus operations team will work very closely. Means at the time of doing the whatever the requirements gathering time, okay, the testing team also will work along with the requirements gathering team, so that they will get the clear picture what they are going to test after the development is complete. Other thing is you have something called the designing. Designing team also, people will interact with the design team, what they want to do once the design is complete. The coding people will interact with the design team. Okay. Similarly, deployment time, the maintenance monitoring team will be involved in the deployment stage. They know that how to monitor those applications kind of thing. Okay. Now that is where the DevOps is the combination of the development plus operations. The total turnaround time it will take, okay, to deliver some features, it will be very fast in the DevOps methodology. Okay, let me see the definition. It's a cultural and professional collaboration and integration between the software developers and IT operations professionals. That's what just now I discussed, right? The different teams, software development teams will be there and operations team will be there. These two teams will work very closely. Okay. So that at the time of doing the development teams, whatever the activities, the operations team also know that what they expect from the development teams. Once the request comes from the development teams, operations team will takes that and process that and produce the given output. Now, in the traditional way, right, the teams often load to slow manual processes and frequent errors. As I said in the waterfall model, right, there is a chance of introducing errors, and also development also will be very slow, and also the manual process. There is no automation involved in the waterfall model. Everybody will do the things manual way and test it and deliver it. If you come to the DevOps model, right, most of the things people try to automate so that you can do the deliverables very fast and turnaround time is less, and also you can make the more deliverables in the less turnaround time. That is the things that you can achieve in the DevOps model. See, the DevOps tools automate and streamline the entire software development lifecycle. The software means this is the software development lifecycle. Your requirements, your design, coding, testing, deployment, and maintenance. All these phases, whatever the maximum possible activities they can try to automate, that you can achieve it in the DevOps lifecycle, so that you can do the faster deliverables and also less error prone and the faster turnaround time. Those things and all you can achieve in the DevOps model. Now, as part of this DevOps model, there is so many tools which are available in the market. Okay, we are going to see those tools. What are the tools available? What is it importance? What are the different operations, okay, that you can perform using those tools? Give me a second. Okay, sorry. Okay, now is that how many of you used the Git tool in your day-to-day life? Git and GitHub, GitLabs, any one of these tools. Anyone used in the maybe IT people knows that who are already there in the IT industry. Now we are going to talk about this. Okay. Now let's talk about Git. Git is the Git and GitHub. We have two tools. Okay, the two ways you can maintain your software using the Git, which is the command line utility, using which you can maintain your software. There's a one more tool called the GitHub. That is a GUI based way of maintaining of your software. See, what are all the different features that developers are developing, if and they want to maintain release by release the different versions of those files, whatever the software they are developing, those things, versions, maintenance, and also proper way of delivering of your software to the end users, that you can achieve it using the Git tool. Okay, the Git, it is a foundation for the modern development. Okay, a distributed version control system that tracks the changes in the source code. Okay, there is something called a distributed version control, and there is another between the centralized versus distributed version control. Okay, the centralized version control means what will happen is uh, multiple developers can't work system. And also, if something goes wrong, okay, your entire whatever the software that the people are developing also, it will disturb in the centralized system. Now, Git, we are telling it as a distributed version control system. Okay, let me talk about a distributed version control system. In the distributed version control system, what will happen is there is a one central software files which is available in the Git repository, and the different people which are working on that Git repository, what they will do, something called Git clone. There is a command called, one second. Okay, I'm talking about Git. Maintain the software of the applications. Okay. Here the main source code is maintained in the GitHub. There is a variant of Git is called GitHub. Okay. The developer will take the copy of the software into their local system and develop the new features. Develop the new features to it. Okay. Now, what I am telling here it is, in a Git, in the distributed version control system, there is the original copy always. Okay, it will be there in the GitHub. There is something called branches you need to understand. Okay, generally the different branches, the Git will Git branches. Okay, here there is a one branch is called main branch or master branch. Okay, and there are something called feature branch. Feature branch will be there, and there is another branches like release branch. Okay, I am talking about some important things. There is something called hotfix branch. Hotfix branch. Like this, the branches will be maintained in the Git. Now, what will happen in the distributed version control system is the different developers which are working on the software, everyone will take the copy of main. There is a command in the Git called a clone. Is a command Git clone of your software application source code path. Okay. Now, if you do Git clone, okay, what will happen is the entire software of your main branch will be copied to your local system. Okay. Then what you will do from the main branch, what you will do, you will derive something called feature branch. Feature branch. Okay. Once if you develop the feature branch, from the feature branch, you will add the new code. Assume that if the main branch, okay, is in version 1.0, version 1.0, then on top of it, what you will do in the feature branch, what you will do, you will add the new code or new application code. You will add the new features to the application code. Once if you develop the new feature to the application code, then what you will do, you will raise something called PR. Means that you will raise the pull request. Pull request. What will happen is, once the pull request is raised, you will merge that newly added feature to the main branch so that it is integrated with the main source code. So that in the distributed version control system, everybody will get a copy of their software and develop their features and merge with the main branch. Whereas in the centralized, one person after other person only will add the features. That is about that. Now, key functions. Now, what are the things that you can achieve out of this is collaboration. What is the collaboration? Allow the multiple developers, that's what I'm talking, right? Allow the multiple developers to work on the same project simultaneously. That is where everyone can work in parallel to develop the new features. What is the second thing? History. What is the history? Creates a complete history of changes, making it easy to revert to previous versions. Here, what will happen is every time when the developer is working on the new feature, the version of that software is get incremented, so that there is something called commit IDs. When I am developed some new feature, once I will merge my code into the main branch, the new commit ID will be generated. Like that, you can maintain the different versions of the software. And branching enables the safe parallel developments for the new features. Okay, that is where every time we are going to parallel developing of the new features without affecting the main code base. Someone can tell me where your main code base is right? And each developer developing their own branch and bringing the versions out of it to merge with the main branch. That is where how the Git will works. Anyone, any questions from the Git? Any doubts or anything anyone or ask any question with respect to this tool, Git?
No,
Any
no,
questions,
the
please?
individual developers developing the components, right? Of, through the Git,
Uh,
the main code base will be in the Git, and they developing
yeah,
the individual components.
yes. And
The,
then whenever the developer develops any of their new code, what they will do, once you can compare your newly developed feature with the main branch, okay, there they will ask, you want to raise the pull request. Then your main version to the feature version, what are the extra code which is there? What is the extra code which is there? Then once you compare your main version to the feature version, what are the extra code which is there? Then once you do the pull request, generally you can't directly merge your newly added feature into the main branch. Then you need to select some reviewers. Who are the reviewers? They are the subject matter experts with respect to that particular features development. Then they will review your code and they will give the confirmation. Okay, whatever the code developed by the new developer is good and implemented as per the standard, and the logic has been implemented properly. After that, they will approve your changes. Once two reviewers, maybe you can set up n number of reviewers, two or three, whatever it is. Once all the three people satisfies that your code, okay, then they will give the approval. Once they will give the approval, then you can merge your newly added code into the main branch, so that once it is get merged with the main branch, okay, then what will happen? The build will trigger there. What is the build? Is nothing but build is nothing but building of your software to create the application package out of it. The application packages generally will call it as a war file or a jar file, or no any other file. If it is a Java, it will create a jar file. If it is or a war file. If it is a Python based, you will call something called another object file. If it is a Node.js, it will create another object file like that. Okay, you will create the image out of it, and then that image, okay, you are going to store into the central repository. To store that, there is other tools available. The tools called JFrog. JFrog is the artifacts repository tool. Or I want to store it in the Git itself. Git has some archival mechanism to store the images. Or I want to store into the cloud environment. In the AWS, you have something called ECR, Elastic Container Registry is one of the service. Once you can configure to store the final artifacts into that particular ECR, still you can store the images there. That way the development happens using the Git. And you need to understand that Git is the command line tool. Okay, there is a one more tool is called GitHub. Now, if you want to differentiate these two, generally people will store the in the GitHub, which is command line tool. Means that initially you will store the software and everything in the GitHub, and then you will clone that to get the entire copy of it into your local system through the Git. And here you can do the modifications, and then you will commit back your changes back into the main branch. Then
Yeah,
you will build
generally
the
they
code.
stored into the
Okay?
repositories, right? So which
Yes,
repository we need to work, we can get it into the system.
you are right. Yeah.
Yeah.
Which repository I want to maintain, in that repository you will upload your new features code. Whenever if you commit any of the new code, the commit id get generated, using which you will come to know what are the changes between the previous commit to the current commit. That all the things, maybe you have to live, you need to practice how to install a Git, how to clone it, and after that how to add the new files, and then how to do the commit of that, how you can merge your branch code into the main branch, and a little bit of if you do a little bit hands-on, you will get the more output out of it. Okay, now we are talking about Git and GitHub. In addition to Git and GitHub, okay, there is a one more tool available called GitLabs. Same thing, but it is a little different. Git and GitLabs is more no, user friendly and more better way you can maintain your software in the GitLabs. That is about the Git. Now let's enter into the another tool called the Jenkins. Now so far what I have explained so far is, only thing is you can develop the software, you can maintain your software in the version control tool called the Git or a GitHub. Once your software is available in the version control tool called GitHub, the next step is, okay, you want to build that software. What is the building of the software? Building up maybe once you are developing of your software, means you are having a lot of source files. Maybe your source code be in Java, or your source code will be in C or C++, or your source code will be in Python or Golang. There's a different programming languages available, using which you can develop the software, which will be there in the GitHub repository. The next step, you want to build that software. Okay, to build the software, there's a one more tool called Jenkins. Okay, which is the open source tool. Only thing is you need to have one server. In the server, you need to go to Jenkins website. There is a binary available to download Jenkins, and you have to follow some instructions to install the Jenkins. Once you install the Jenkins, okay, you can log into the Jenkins from the browser also. Once you log into the Jenkins, you will get the Jenkins interface. Okay, in the Jenkins, you can able to build your GitHub software application source code, whatever that you have. Now let's talk little more into the Jenkins. What way the Jenkins is useful is, it is called the CI/CD automation engine. Here the CI stands for continuous integration. In the Jenkins, it is the, they are telling that it is the CI/CD tool. Okay, what is CI, what is CD, we will know. Okay, CI stands for continuous integration. Okay, I will tell that what is the continuous integration. What is CD? CD is called continuous deployment. Continuous deployment, or it is delivery. Okay. If anyone have the doubts, you can raise the hand. I can clarify your doubts. Okay. Now, whatever the GitHub, which is having the application software, you are taking that end software code. Okay. And in the Jenkins, there is something called plugins concept is there. What is the plugins? Through Jenkins, you can talk to your GitHub source code. Okay. Through Jenkins, you can talk to other DevOps tools also. Like I want to talk to, for example, Cloud, or I want to talk to my other Sonar Cube. There is other tools available. That kind of facility available in the Jenkins. Through plugins, you can interact with other components. You need to do some setup and configuration to talk to other components. Okay, using which you can tell that which is the GitHub source code I want to build. Maybe for example, let me show this thing so you understand. 1 second. For example, sorry. Why it is came like this? Wait. Okay. Now I will go to github.com. Let's go to GitHub. I will just try to log in and show you quickly. Then I will switch into the Jenkins. Here I can sign in. Okay. Let me use my credentials. So continue with Google. Link written. Okay. So it will send some. 1 second. I want to enter the SMS code here. Send SMS. I got SMS. 1 second. Where is my Gmail? Yeah. Some code will come here. Continue. Google Pen green. Send it posted. I think I need to enter some code. See, what will happen is once I enter the code, I can get the GitHub URL. In that, I'm maintaining some software application code into the different projects. Okay, using which I can enter my software code where it is residing into the Jenkins, and I can select the type of builds using which I can build the software. See, it is the CI/CD automation engine and open source automation server for building. What it will do, it will build your software image out of it. Once the image is available here, once if you build it and you want to install that image onto the remote server, the remote server will be your data center server, or you can take one of the server from the AWS cloud or Azure. You can transfer this application code into there, and then you can launch that application. Once the building is done, people will do the different testing on the application. Make sure that all the features of the application working properly or not. All those things you can achieve in the Jenkins. And deploying of the software projects. And once the testing is completed, everything is working fine. Deployment. What is the deployment? The remote end user server where this application is going to run. That is where I'm going to deploy the software projects. Case, it monitors the code repository for the new commits. See, every time develop some 5 features, then the build happened, testing happened, deployment happened. Now another project team added some new features out of it. Okay, they will do the building, testing, and deployment. This way, keep on continuously adding up the new features that you can achieve it using the Jenkins. That is called the continuous integration. The continuous integration is nothing but, let me go there. The continuous integration means, see, initially when you develop the software, there are the 5 features, okay? 5 software. Now, continuous integration means on top of it, I have developed additional 4 features. This is nothing but integrating of the new features with the old features. That is called the continuous integration. Whenever if you add the new feature integrated with the old features, the final application features, what you will do? You will do the deployment. What is the deployment? You will do the deployment not manual way. You are going to do this deployment with the automated scripts. That is called the pipeline. That is called the pipeline. Jenkins have the pipeline concept. Pipeline concept means you can write a code to build, test, and deployment everything through automation scripts. That is called the pipeline. You will deploy onto the remote server. Deploy onto the remote server. Which are the remote servers means on the center you have servers, or you can deploy onto the cloud. In the cloud there is something called EKS clusters. Okay, that is where applications is going to reside. People can access that applications for their business purpose. That is what the continuous deployment you can achieve it in the Jenkins tool. Okay, now monitors the code repository and commits, automatically triggers the pipeline. That's what I'm talking about. Jenkins provide the concept called the pipeline. The pipeline again is a Groovy script, or it could be YML script. People write the different stages in the pipeline. Based on the stages defined, stage by stage, the code is get executed, and automatically it will build, test, and deployment onto the remote servers. So that Jenkins, the main thing you need to know, it will provide something called pipeline. Using the pipeline, everything it will do automatically. There is no manual intervention. Okay. Once if you trigger the Jenkins pipeline, all the stages get executed, and the final software application code get it deployed onto the remote servers. The pipeline means all these stages: compiling stage, running, they run the test, deployment, everything get included in the pipeline. And also it provides the instant feedback to the build success or a failures. Assume that while building of your software, it is not compulsory that it will build the software package successfully. Sometimes if there is some problem in the code, your build may fail. If any build failure happens, what are the things that you will do? You have to go through the build log, and you need to analyze the logs and try to fix the problems. If build is successful, the image get created out of it. You can store that image into the artifacts repository called JFrog, or you can store it in the EKS cluster called ECR, Elastic Container Registry. From there, you can deploy onto the remote end server. That is called EKS cluster. That is about Jenkins. Okay, and next we are going to talk about Docker. Any questions in Jenkins? Quickly, I will take one question. We don't have, what is the time now? Let me see the time. Now it is 8:20. Maybe I may take the class till 9 p.m. That is my plan. Let's see. Any questions in the Jenkins from anyone? Any questions, please?
Sudeep, you have any questions?
Okay, no problem. Fine. How many we have on the current live? Just check it.
2 members are there, sir.
Only 2 are there. Okay. Fine. I will take maximum up to 9, but there's so many things, but we can cover what is the best possible till 9 p.m. Okay.
Yes, sir. Yes, sir.
Okay. Fine. That is about the Jenkins. Jenkins mainly using for building, testing, deployment, and maintenance. Next, let's talk about Docker. What is the difference? What is the Docker, first of all? Why Docker came into the market? What is it benefits? Why everyone is going for the Docker containers instead of the normal way of building applications? We are going to see that. Just give me a second. Okay, let me tell the normal way of deploying of applications. Previously, built the application we are going to deploy it onto the physical servers. What are the physical servers? Maybe once if you buy any of the server from the markets, it is a huge capacities of CPU, disk, and your memory. Okay. In the olden days, people to deploy onto the entire server. Later, after the physical server, in the computer world, it is something called virtualization came into the picture. The existing physical server, they used to fragment it, not fragment, they used to divide that physical server to make into the different virtual machines. That is the second level of abstraction, second level of virtualization they brought in. Now, in the third level of virtualization, within the virtual server, okay, instead of wasting the lot of CPU memory or disk, you can further maintain your resources much better in your virtual machine by introducing something called Docker engine. Okay, what is the Docker engine? It will divide your total virtual system again into the different Docker images. That is very tiny components called the microservices concept, that is more will be used in the Dockers. See, consistent environments for the applications. Maybe my application need only, 2 CPU, and I want 4 GB RAM and some 20 GB of hard disk. My virtual capacity is very high, so that within the one virtual system, I can create the multiple Docker containers and use it for my applications in the better way. That is what you can achieve in the Dockers. Now, a platform that packages the applications and all its dependencies means that if I want to run my Python application in my Docker container, what I will do, I will take the base operating system, for example, very lightweight operating system like a Alpine. On top of it, I will load my Python application. And then on top of it, I can load my source code, actual customer end user application, and then create the Docker image out of it. And the Docker image, I can deploy it onto any of the virtual servers. That is where, it's very tiny things to maintain to deploying and maintaining of your applications. Platform packages and applications and all its dependencies. Maybe if my applications wants to run, I need some libraries or I want some configurations to be done, okay, into a single thing. The isolated unit, that is called the container. Means that when I want to build my application, I can create a Docker image out of it. From the Docker image, there are some commands available to create the container from the Docker image, like a Docker execute or Docker build. It will create the Docker image. From the Docker image, I want to make a container out of it. To make the container, there are the Docker commands available. For example, what are those commands is, let me talk the Docker, right? Docker. And you need to know Docker commands. What are the Docker commands? You have first command is called Docker build. Okay. There is a command called Docker run. Docker run. There is a command called Docker execute. Exec. There is a command called Docker push. Okay. Command called Docker pull. These are all the different. There's so many commands, but I'm talking about few commands here. There is some Docker prune. Okay. There is a command called Docker push, Docker ps, like this commands. Then Docker kill command is there, Docker delete is there, like that. Docker delete. Okay, these are the list of Docker commands. Now, using these commands, once you will make the Docker build, what it will do, it will create the Docker image. It will create the Docker image. Once the Docker image is run, I want to make a container out of it. Then I can run the second command called the Docker run. It will create the container for the Docker image, Then Docker execute. What it will do? Allow to log into the container. Log into the container. You can go inside the container where your application is loaded. And if you want to do some configurations and all, you can log into the container, do your configurations, and you can do some configuration changes. What is the Docker push? It will upload your Docker image to the central repository. Central repository called Docker Hub. It will upload into Docker Hub. What is the next one? Docker pull. And I want to download something. It will download the image from Docker Hub to your local system. Like this, commands will be used. Containers, I want to delete the containers. For that purpose, other things will be used. It will know the status of the Docker process. Like this, commands are there. Okay, I'm not writing everything because of the time. Okay, now let me 1 second. How to 1 second. Okay. Now, give me. Does anyone use Docker containers in your previous experience? Okay, let me talk a little bit more about this. The Docker is a very tiny image. Okay, you can create along with your libraries and configuration changes to create the Docker images. Because of doing like this, you can save the lot of system resources like CPU, memory, and the hard disk. Okay, you can make it as very simple Docker image file. And this Docker image file, very portable thing. You can port it onto any of your virtual systems. You can run it from. Now, a containerized application runs identically in any of the machines with the Docker installed. And any system, wherever if you install the Docker engine, right, you can take Docker image there. From the Docker engine, you can run the Docker commands to make the container out of it, and then you can run the container. What are the other important thing you can get with the Docker containers is efficiency. Containers are lightweight. Like a virtual system, if you take now, it will utilize the more resources like CPU, memory, and hard disk.
Sir,
Yeah.
hello, Jairam sir.
Yeah.
Participants are left, sir.
Oh, all are left, huh? Fine.
Yeah, sir.
No problem.
It's 8:30.
Yeah, no problem. We can stop here. Maybe next
Yes.
time when there is any other option comes, we'll continue the remaining things. Okay?
Yes, sir. Yes, sir.
Yeah. We'll stop here.
Definitely, sir.
No problem. Yeah.
Thank you, sir. Thank you so much, sir.
Fine.
Thank
Actually,
you.
we have it may take another 2 more sessions like this. We have so many things to cover. We will get next sessions. Huh?
Definitely, sir.
Okay. Then.
But today, hello.
Tell me.
Jairam sir, today you taken 7:30. No, that's the problem, I think.
Understand, but I went out of station. To reach home,
okay.
Became around 7:15. Then I started at 7:20.
Yeah, it's okay.
No problem. Next time we'll plan it at 7 o'clock.
Yeah, I will ask Pradeep to conduct once again, sir.
Okay, fine. No problem. Yeah, thank you.
Thank you, sir. Thank you.
Yeah. Bye.